We're going to look at how we use the trapezoidal rule and the midpoint rule to approximate an integral accurate to 6 decimal places. And for this example, our integral is the integral from 0 to 4 of the square root of y times the cosine of y dy. And we're going to let n equal 8. Those are all in the instructions. For ease of writing, we're going to say let the integral be represented by I. All right, for part A, the trapezoidal rule, we need to know what our input values are. Our interval goes from 0 to 4, and if n is equal to 8, then I know that delta x is equal to 1/2, and our interval has endpoints of 0, 1/2, 1, 3/2, all the way up to 4. I then, which is approximated by t sub 8 in this case, is equal to delta x over 2, and so 1/4, times f of x sub 0, so f of 0, which means the square root of 0 times the cosine of 0, plus 2 times the square root of 1/2 times the cosine of 1/2, plus 2 times the square root of 1 times the cosine of 1, plus dot dot dot, plus 2 times the square root of 7/2 times the cosine of 7/2, plus the square root of 4 times the cosine of 4. This is a messy calculator exercise. We're going to see how we can use Excel to make the work less painful. Here's my Excel spreadsheet, and I'm going to just put some notes to myself in the top of each column. We'll need an x sub I, and then the function value at those. So it's going to be square root of x sub I times the cosine of x sub I. It won't do anything the way I'm typing it now. This is, like I said, just notes to myself. We're going to need the coefficients, and then we need the coefficients times f of x sub I. Now, our x sub i's are going to be 0, 1/2, 1, and at this point, I'm just going to make use of the fact that Excel recognizes patterns. And I'm going to click down here. You notice after 1, there's a little kind of a green square in the bottom right corner, and then the cursor turns from a white plus to a black plus. I'm going to pull that down until it gives me a value of 4. So I just don't have to type in all those numbers. Wouldn't have been a big deal in this case, but what if n was 100, right? Now, I want Excel to compute the square root of x sub I times the cosine of x sub I depending on what x sub I is. And so I'm going to type in equals, don't forget the equals sign. SQRT is how Excel knows to do a square root. And then I'm going to click in the cell on the left, click, in the parenthesis there, times the cosine. Excel knows what the cosine is. Parentheses times click on the left, enter. Now again, well, it's giving us 0 because we have 0 times whatever. It's 0. But now now I'm gonna drag this down here, and it fills in all of the values for all of the inputs that we wrote down. Now I need the pattern of coefficients, and for the midpoint, for the trapezoidal rule, it's 1, a bunch of 2's, and then 1 at the end. As far as the sum, it's the function value times the coefficient, and I didn't click equal sign, that messed everything up. Function value times the coefficient, enter, and I know I could just type in, times 2 every time, but I didn't want to. And there it is. So we have this, all these values for each of the terms inside the midpoint rule. Inside the trapezoidal rule. I'll get it straight, folks, I swear. Now for our trapezoidal rule, we need a delta x, and the delta x is 1/2, right? We already figured that out. And now I'm ready to put all this together. We'll say that the result is equal to delta x divided by 2. Remember, that was part of the midpoint or the trapezoidal rule, I swear I'm going to get this straight, times the sum of all of those things that we multiplied together, enter. This cell at the end here is the one that contains the answer that we're after. So if we go back to our notes here, we can say that the integral, which is approximated by t sub 8, is going to be given by approximately negative 2.364034. And I just realized I need to approximate the t sub 8 because we rounded there as well. But there it is for the trapezoidal rule. There, I finally got it straight. For part B, we're using the midpoint rule, and we're going to do something similar, but we're going to have different input values. We're still going from 0 to 4, and n is still equal to 8, so we still care about the values 0, 1/2, 1, 3/2, etc. But we're going to use the midpoint of each of these subintervals. And so our x sub I values are going to be 1/4, 3/4, 5/4, and so on up to 15/4. I, which is going to be given by, or approximated by m sub 8, is equal to 1/2, that's our delta x, times the square root of 1/4 times the cosine of 1/4 plus the square root of 3/4 times the cosine of 3/4 plus ... all the way up to the square root of 15/4 times the cosine of 15/4. And to compute this, we're going to go back to Excel. We need to change some things here. Our x sub i's should be 0.25, 0.75, and so on. And once you have two of them, Excel recognizes the pattern. And we're going to end that at 3.75 because that represents 15/4. So we're actually going to get rid of this last row here. And then I've already got the formulas that depend on those inputs. What we need to change are the coefficients. The coefficients don't have that 1, 2, 2, 2, 1 pattern for the midpoint rule. And then finally, delta x is the same, but for the sum, we need to get rid of this 1/2, right? There was no delta x over 2 for the midpoint rule. And here we have our answer. So Excel not only makes it easier to perform repeated computations, but it also makes it easier to make some changes and generate an entirely new computation. We can go ahead and write down this answer now. I, which is approximated by m sub 8, is approximately negative 2.310690, and that's to 6 decimal places. And we see that there's some discrepancy here in the two values, but they're close-ish together. But we knew that there was going to be some error. For your homework, you're absolutely welcome to use Excel to generate these values. Just, write down something that tells me that you did some work and you have the answer. And this won't be an issue for exams, but yes, you can use Excel for your homework.